Hey guys, today I'm just going to go over your study guide. By the end of this lesson, you should be able to review exponents in the real number system, which was our first unit, and focus on any areas of improvement. That's really important for today. Anything that you don't remember or you're struggling with, that's where I want you to focus. Not the stuff that you're great at, the stuff that you need to remember. So go ahead and get out your binder, turn to the math section, get out your study guide, and get ready to review. All right, so let me get started by just explaining how I think this should work for you. You should go ahead and do the study guide first. So before you've watched this video, you want to go ahead and try everything on the study guide for yourself. Then you have the answer key posted. So I want you to look at the answer key and check all of your work. Then you can pull up this video, and you should have pulled up this video now to go through and look at explaining how each problem works and how each problem I got my answer if you got something different. You don't need to waste your time on problems that you got correct or you know how to do. Just review the things that you don't remember or that you missed. So I'm going to go ahead and get started just going through these problems. Each problem represents the types of questions on your test. So make sure you ask questions if you need help with the topic. And as I go through it, I'm just going to explain how I would do it. So the first thing we know how to do now is we can evaluate square roots of small perfect squares. That was our I can. This is our standard. This is what all Kentucky teachers have to teach for their 8th grade math classes. So this is 8th grade expressions and equations, lesson 2. So let's look at the first question. It says, evaluate the following, and you have all these square roots, but they each have an operation next to them. So let's look at A first. We want to start using our PEMDAS, doing what's inside of the exponent or square root first. So we get the square root of 49. We know the square root of 49 is 7 because 7 times 7 gives you 49. And if there's a 2 on the outside, that's like multiplying. So if there's a 2 on the outside of something or any number on the outside of a parentheses, a square root, whatever, it means multiply. So 2 times 7 gives you 14. 14 is your final answer. The same thing goes for B. The square root of 100 is 10, and then there's a negative on the outside, so just make it negative. So negative 10 is your final answer. The last one says take the square root of 169 and then add 10 to it. So the square root of 169 is 13, because 13 times 13 is 169, and then add 10 is your last step. So 10 plus 13 is 23. Let's look at number 2. It says the square pool, so we see a square, at Sammy's gym has an area of 144 square feet. So I'm going to draw the pool, and the inside is 144 square feet. So what you are looking for is the length of one side of the pool. So we want to know just the length of one side. You're given the area, which is the same as length times width. So we know that something was multiplied by itself, because it's a square, to get you 144. So you're trying to think what number times itself equals 144. So we are going to take the square root of 144 to find the length of one side. So that equals 12, because 12 times 12 is 144. And the units are feet, so the length of one side is just 12 feet. Make sure you put your units. Number 3 says Elena bought a square frame for her desk, so it's another square. So I always want to just draw a square and realize that all of these sides are the same length because it's a square. It has an area of 81 square inches, so the same thing as the last one. 81 square inches is the area. What's the perimeter of the frame? So perimeter means all of the sides added up. So we'll start by finding the length of just one side. I know all the sides are the same, and I know that the length times the width gave me the area. So I'm thinking what number times itself gave me 81. This is the same thing as thinking what's the square root of 81. That is 9. So I know the length of one side is 9, but it's asking for the perimeter. Perimeter means all the sides added up. So you can think of this as 9 plus 9 plus 9 plus 9, or you can think of it as 9 times 4, since there's 4 sides. You'll get the same answer, 36 inches. Number 4 has an open answer. You could have many different answers, but it says give an example of a fraction that could be represented as a repeating decimal. So anything divided by 3 or divided by 9 are going to be repeating decimals. So remember, anything over 9, so you could have 7/9, 5/9. Anything with a 9 on the bottom is usually our go-to example for a repeating decimal. If you aren't sure, you can ask me or you can check on your calculator. Just type it in, and instead of putting it as a fraction, type 5 divided by 9 or 7 divided by 9, and you should get a repeating decimal. Number 5 is the opposite. It says give an example of a fraction that could be represented as a terminating decimal. Terminating means ending. So it comes to an end. 1/2 is the go-to for me because that's 0.5. There's nothing after that 5 except zeros. You could have also put 3/4. That's 0.75. So anything that comes to an end, if you aren't sure, type it in the calculator. 1 divided by 2. And if it ends, then you are a terminating decimal. Number 6 says Ricky ran 7/16 of a mile before stopping to tie his shoe. Represent the distance as a decimal. Then state if the decimal is terminating or repeating. I'm going to show you very quickly how to do this without a calculator, But if you had a calculator, you would just type in 7 divided by 16. This is how I would set up my problem. I put the 7 on the inside and the 16 on the outside. 16 isn't going to 7, so I have to add 0 placeholders. So I just add a few of them until I'm happy. I might need to add more as we go. And I want to think, how many times does 16 go into 70 now? 16 can go into 70 4 times, because 4 times 16 is 64. So then I bring that down and subtract. I have 6 left, and I have 60 now, because I bring down this 0 to figure out how many times 16 goes into the number 60. That would be 3 whole times, because 16 times 3 is 48. You subtract to get 12. 16 doesn't go into 12, so I drop down another 0. 16 goes into 120 7 times, because 16 times 7 is 112. I subtract again. I get 8, and then I bring down another 0. So if I don't have one, I need to get one. So I can extend my line out, keep adding placeholder zeros, make this an 80. 16 goes into 80 evenly 5 times. Since 16 times 5 is 80, I can just show you right here I have no remainder. I bring my decimal point up top because I had it right here. It's lined up. So my final answer is 0.4375. So with a calculator or without a calculator, you should get the same answer. This might be a question that you could see without a calculator, so make sure you understand how to do long division. And then the decimal is terminating because it has an end. Let's look at number 7. It says Emily ended up using 7/3 cups of flour in a recipe for cookies. Express the amount of flour she used as a decimal, then state if it's terminating or repeating. If you use your calculator, you would just type in 7 divided by 3, but I'll show you quickly without a calculator. So some of you guys might have tried to set your problem up like this. However, it's not 3 over 7, it's 7 over 3. So we want to make sure that you have 3 on the outside, 7 on the inside. 3 goes into 7 2 whole times, and then that makes 6 because 2 times 3 is 6. We have 1 left over, so we're going to keep going. So when we want to keep going, we just have to add decimals and then placeholder zeros. This is just a review of long division. Because I put a decimal here, I'm going to put a decimal up top in our final answer. So we're trying to find the quotient. I'm going to bring down this placeholder 0. Now I'm thinking, how many times does 3 go into 10 evenly? It goes in 3 whole times. 3 times 3 is 9 with a 1 remainder. So you can start seeing a pattern. I bring down a 0. It goes in 3 times. 3 times 3 is 9, and I'm going to continue going on and on and on forever. So that means that my final answer would be 2.3 repeating. If a decimal is repeating, I can go ahead and just put the line over top of it to show that it's repeating. This is a repeating decimal. So that whole section was about representing rational numbers as decimals. This is your first standard in 8th grade math. The next section is going to be the same thing, representing decimals as rational numbers. So we're going to look and get a decimal, and we're going to make it a fraction. So all rational numbers are decimals and fractions and integers, but we're going to go ahead and represent this decimal as a fraction. So on your calculator, you might have a button that says fraction to decimal or decimal to fraction. You also might be able to recognize that this is 125 thousandths. You could write that as a fraction right there, but then we could also go back to our note sheet and remember that we have a process for this. So I'll go through that process with you very quickly. So the steps for making this a fraction is to go ahead and start by making it over 1 and then multiplying by 10 over 10 until you get rid of that decimal. So we multiply the top by 10. We're just moving the decimal over 1 time. So we have 1.25 over 10. And we're going to have to keep going until we get rid of that decimal completely. We want whole integer numbers. So I keep doing that until I end up with 125 thousandths. If I read it out loud and I realized that was in the thousandths place, I could read it as 125 thousandths. Then the next step would be to simplify my fraction. So I know that these are both numbers divisible by 5, so I could just start by dividing by 5. If I do 125 divided by 5, I get 25. If I do 1,000 divided by 5, I get 200. So now my new fraction is 25 over 200. They're both still ending in 5 or 0, so they're both divisible by 5 still, so I can just keep dividing by 5. There's also other ways to simplify fractions that are easier, but this is how I would do it if I didn't know exactly what number went into 125 and 1,000. Then the last step, you can see that 5 goes into 5 one time, and 5 goes into 40 8 times for your final answer of 1/8. So 1/8 is the fraction version of 0.125 in simplest form. Number 9 says express negative 0.4 as a fraction in simplest form. I'm just going to show you with the shortcut. If I was going to read this, it's 0.4, but I know that it's in the tenths place. So when you look at your place value you learned back in probably 4th grade, after the decimal, there's a place called the tenths place. This is the same thing as 4/10, and it's negative. I can simplify this. It tells me to write it in simplest form, so I know that's a clue that I have to simplify it. That means I know that there's a number that goes into both 4 and 10. 2 goes into 4 and 2 goes into 10. So if I divide out of 2, 4 divided by 2 is 2 and 10 divided by 2 is 5. Keep the negative and that is your final answer. Number 10, there's a little trick too. It says express 0.5 repeating as a fraction in simplest form. If it's a 5 repeating like that and it's just a 5, I know that my denominator is 9 because 0.5 would be out of 10. So go one less and you have a repeating 0.5. So 5/9 would be your answer for number 10. Number 11 says express 0.15 repeating as a fraction in simplest form. There is a mathematical way to do this, but I am just not going to go through it with you right now because it confuses me, to be honest with you. If you want to look up how to do these kind of problems, you go for it. But I'm just going to go straight to my calculator. And if you don't have a calculator and you have to try some stuff out, I would always try some numbers over 3, over 9, over 33. All those numbers are going to be things that end up with repeating decimals. But like I said, I'm going to go to the Desmos calculator. I'm going to type in 0.1515151515, a whole bunch, and then I'm going to click turn it into a fraction, and it's going to say 5 over 33. So that's your final answer. And I'm sorry that I can't go into that in more detail, but that is a tricky one, and you might need just that calculator for these. The next thing you should be able to do now is classify real numbers. So we looked at this like it was Ethan going to camp, and we looked at with the dog system, and we looked at just how we classify animals, how we relate people to each other, and then we looked at integers, whole numbers, natural numbers, and we started realizing there are some irrational numbers, there are some rational numbers, and reasons why. So in this section, we're going to fill in the first blank of each sentence with either rational or irrational, just starting with those two basics. Then we'll fill in the second blank with our justification. So for A, 0.87 is rational because it's a terminating decimal. So all rational numbers have decimals that end or repeat. All rational numbers are fractions. All rational numbers can be integers. So rational, repeat. Rational, terminate. For B, you want to simplify first. So you want to simplify the square root of 121, which is 11. And then there's a negative on the outside. That means it's rational. You can write it as a fraction. The fraction version would be over 1, and it is actually an integer. All integers are rational numbers, and all perfect squares are rational numbers. So any perfect square is a rational number. So for that one, I just wrote down it's a perfect square, but you could write down because it has a terminating decimal. You can write down because it's an integer. You can write down because you can write it as a fraction. So there's a lot of different answers you could have for B. Let's look at C. You have 19 over 99. If you type that in the calculator, you're going to get a repeating decimal. If it repeats, it's rational. Your other clue is that it's a fraction, so it's rational. So your answer could be either you can write it as a fraction or it's a repeating decimal. Let's look at D. It says the square root of 70. So try to simplify that. You're thinking what number times itself gives you the number 70? Well, I know 6 times 6 is 36. I know 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. I'm thinking of these perfect squares. None of them equal 70. None of your doubles will equal 70. If you type it in the calculator, you would get a decimal that never ends and never repeats. So this means that the square root of 70 is a non-perfect square. It is irrational. The last one, 0.72 repeating. When we try to decide if a fraction or a decimal is rational or irrational, if it's a decimal, the rule is, does it end or does it repeat? If it does either of those things, it is rational. Rational, repeat. Rational, repeat. So for the same reason as C, it is a rational number because it's a repeating decimal. So for number 13, it says this set of values below contains only irrational numbers. So all these are irrational, which would be the fourth value in the set. So in this set, you want to pick the irrational number out of it. So we want to cross out anything that is a fraction. Fractions are rational. So B cannot be the irrational number. A is a terminating decimal. Those are rational. And then D has a repeating decimal. Those are rational. So the only one left is 3 pi. So anything to do with pi is irrational. It's the most famous irrational number. So your answer should be C. Number 14 gives you an example where Cameron classified the number negative 18 over 3 as real, rational, integer, and a whole number. We're going to determine whether he's correct and then why or why not. So the first thing we do when we get a fraction like this is try to simplify it. If we can because 18 divided by 3 is 6. So we have a negative 6. So already we know that the number is real because all numbers we know are real. It's rational because it is an integer. So it is an integer because it's a positive or negative whole number. So it's an integer. And then he classifies it as a whole number. However, negatives cannot be whole numbers. You can never have a negative whole number. So he is incorrect because you can never have a negative whole number. It's only real, rational, and an integer. So for 15, we're going to continue to classify real numbers. So we're going to classify this number to all of the number sets which they belong. So you might want to skip ahead and look at the graphic organizer that we made and start thinking about this like that. So I'm going to classify A, negative 18.75 as real to start with. Always start at real and go down. All numbers we know right now are real. The next category is rational because it's a terminating decimal. So it's rational because there's a 0.75, so it's a rational number, has a terminating decimal. That's it. There is nothing else after that because the next thing after that could be, is it an integer? And it's not because it has a decimal. So anything that has a decimal, that makes it rational. For B, I want to simplify it if I can. So the square root of 36 is 6. So 6 is real. 6 is rational. 6 is an integer. 6 is a whole number. And 6 is a natural number or a counting number because you can count to 6. So all these whole basic numbers that you can count to, those are natural. Those are all of the above. Real, rational, integer, whole, natural. The only thing that it is not is irrational. This is not an irrational number. C, on the other hand, has pi squared, the most famous irrational number. So all numbers are real. We know numbers, they're real. Everything is here that we know. And then it is irrational because it doesn't make sense. Pi never ends and pi never repeats. So that's pi. So for 16, we're going to use that graphic organizer. So I'm going to go ahead and just label it for you real quick. E is irrational numbers. These are numbers that don't fit into the set. A would be rational numbers. B gets a little more specific. Those are integers. C is whole numbers. All whole numbers include 0 and then up to positive numbers. So D is natural numbers. That's everything except 0. So now we look at A, 0, what's the smallest set that it belongs in? That would be C. C is a whole number, or 0 is a whole number, but it's also an integer, rational, and so on. It's not natural, it's whole. The square root of 3 is E, irrational, because it doesn't make sense. No number times itself equals 3. 8 over 5 is a fraction, and you cannot, when you simplify it, you'll get a decimal. You can't write it as a whole, positive, or negative number, so it is just A, rational. D, on the other hand, you can simplify. 14 over 7 is negative 2. When you have a negative on the outside, it makes it negative 2. So that's B, an integer value. Then the square root of 25 is 5. So that makes it a natural number or a counting number. This section is mainly just definitions using that chart. Go back and watch the video on that one if you have any problems with this one. Let's look at 17. It says label the following statements as true or false. So we have a few different statements. Let's go through each one. Every real number is a rational number. So every real number is rational. So all of these are real numbers in the whole box, and irrational numbers are in that box. So that's actually false. That would be false. Every real number is not rational because they could also be irrational. B says every whole number is an integer. So every whole number is an integer. That's like saying every border collie is a dog. That is true. C says some irrational numbers are integers. So some of these irrational numbers are in this whole other box. That's false. They're only irrational. And then this last one says some integers are natural numbers. So some integers, for example, could be 5, 6, 7. Some of those, yeah, some of those are natural. So some of those are natural. Not all of them, because some of those are negatives, and negatives can't be natural. But some of the positive integers are natural numbers. Let's look at this last page. We can approximate the value of irrational numbers. Between which two whole numbers does the square root of 150 lie? So 150 is not a perfect square, but it lies between two numbers, two perfect square numbers. So I'm going to look at the perfect square values on either side of it. I know 144 is a perfect square, and I know that 169 is a perfect square. Those are the two that are between 150, or 150 is between, and the square root of 144 is 12. The square root of 169 is 13. So it's between 12 and 13. For me, solving problems like that, it helps me make a list of my doubles off to the side of my paper. So I just off to the side write 1 times 1 equals 1, 2 times 2 equals 4. Make a list of all my doubles, and then I look at where 150 would fall between. Let's look at number 19. It says, which of the following is a true statement? The correct answer is B, because the square root of 7 is between the square root of 4 and the square root of 9. So the square root of 7 would be between those two numbers, represented by 2 and 3. So for number 20, it says a square sandbox. So we're going to draw the square, has an area of 75 square feet. So the same thing we did with perfect squares. we're going to estimate the length of one of the sides. That means you're going to take the square root of 75. So when we want to find the length of one side, we take the square root. If you're given the area, you take the square root. So the square root of 75 is not a perfect square, but we can estimate it either using a calculator or by looking at our irrational number line. We know it's going to be between 8 and 9 because 8 times 8 is 64, 9 times 9 is 81, and 75 falls between those two numbers. So it's about 8.6 because it's a little closer to the 81 than the 64. You should also be able to then locate those irrational numbers on a number line. So for number 21, Shiloh estimated that the square root of 190 was here because she placed a point on the number line below. How could that estimate be improved? So how can we make this estimate better? So let's look at what 13 is as a square root. So 13 times 13 is 169. Let's look at what 14 times 14 is. Just quickly on the calculator, I typed in 14 times 14, and I got 196. So the square root of that number would be 14. The square root of 169 is 13. So the square root of 190 should be really close to 196. So this estimate is too low. It should be closer to the 14 than the 13 because the number square root of 190 is closer to the square root of 196. So we'll do the same thing for number 22. It says which point below is the best estimate for the square root of 5. We'll start by looking at, we have 2 and 3, their square root equivalents. So we'll look at their doubles. So just 2 times 2 is 4. So the square root of 4 is 2. 3 times 3 is 9. So the square root of 9 is 3. And then we're going to estimate the square root of 5. So it's going to be a little closer to the square root of 4. So it's going to be A, about 2.2. So it's going to be closer to 2 than 2.5. We'll do the same thing for number 23. When we're looking at these numbers 8 and 9, we want to look at their square root equivalents. So we look at their doubles. 8 times 8 is 64. So the square root of 64 is 8. 9 times 9 is 81. The square root of 81 is 9. And we're going to think what's right between 64 and 81. So it can't be 80 because that is too close to 81. And since it's right in the middle, it also can't be 67 because that is too close to 64. So the square root of 72 is perfect because it is right between 64 and 81, and this point is right between this 8 and 9. 24 says this point below best represents which of the following? So we're going to do the same thing that we just did in that last example. We're going to look at the square root equivalents of 11 and 12. So 11 times 11 is 121. So the square root of 121 is 11. 12 times 12 is 144. So the square root of 144 is 12. And then we're going to look at each one of these and make sure that what is closest to 144 would be 142. It can't be 146 because that's too high, and it can't be 125 because that's too low. So about square root of 142 would be about 11.89, something that's really close to 12. All right, so we're almost done with this section. So the last section is I can compare the size of numbers. So we're going to order some irrational numbers and rational numbers. It says which of the following real numbers has the smallest value? The way to compare numbers, whether they're rational, irrational, or whatever, is to estimate them as decimals. We want to approximate these numbers as decimals. So you have a 7.1 already, so we're going to leave that as 7.1. You have 6 times pi. So pi is about 3.14. So about 3 times 6. So since it's got a little bit extra, it's going to be 18 and some change, we'll say. So 18 point something. 20 divided by 3, I can do real quick and get 6.6. And then square root of 51 is between the square root of 49 and another number, which is about 7 point something, because that's the square root of 49, so 7 point something. We can already tell that the smallest value is going to be this 6.6 or the 20 over 3. Just by comparing what's in the ones place, a 7, an 18, a 6, and a 7, this number is definitely going to be the smallest. So it's just estimations, but we know that that is the smallest value. So we'll do the same thing for number 26. It says which of the following real numbers has the greatest value? So I want to go through and I just want to estimate all these numbers as decimals. So 13.09 can stay. 13 and 1/5 we need to convert to a decimal. So the 13 will be there as a whole number, and then 1/5 we need to convert to a decimal, so we have 0.2. So we can already tell that 13.2 is bigger than 13.09. The square root of 169 is 13. 13 times 13 equals 169. And then we have a 13.1 repeating. So that's like 13.11111. So we are going to look at all these numbers, and they're all the same ones place or tens place. 13, 13, 13, and 13. So you have to look after the decimal. So we'll look in the tenths place. This one has a 0, and this one has a 2. So it's not this one. We just want to cross them out as we go, just compare two at a time. This one has a 2 in the 10th place. So this one has nothing in the ones digit or the 10th place. So this is a regular 13, so we can cross that one out. And then this one has a 1 in the 10th place. This one has a 2 in the 10th place. 2 is bigger than 1, so 13.2. 27 says fill in the blank with the correct inequality symbol. Remember, those are your greater than or less thans. So you're comparing 4 plus square root of 15 and 3 plus square root of 6. If you look at the one on the left, 4 and the square root of 15 are going to give you bigger numbers. So that's automatically going to make it bigger. So you'll use the greater than symbol. Remember, it's like an alligator eating the bigger number. So imagine that alligator on there. 28, you're going to do the same thing. The square root of 95 is between square root of 81 and the square root of 100, which is 9 and 10. It's closer to 100, so it's 9.7 approximately. So it's definitely bigger than 9.2. For 29, we're ordering rational and irrational numbers on a number line. So you want to make sure they're all in the same form. I make them all decimals. So you do 3 divided by 2 is 1.5, and it's a negative. So just write that down off underneath of it. Negative 2 times the square root of 2. You can just type that in the calculator or realize that the square root of 2 is about 1 point something. And you'll end up with a number a little less than negative 3 or greater than negative 3, but about negative 2.8 is what I got. And then negative pi is negative 3.14 approximately. Remember, that's an irrational number, so that's an approximation, not an exact number. So when it says list them in ascending order, that means it's getting bigger, least to greatest. So right now they're in descending order because they get smaller. So ascending order would be the opposite. So you would have negative 3.14 is the smallest number, then negative 2.8. So remember, the bigger the negative, the smaller the number. So this would be the correct answer. So this is the same type of question, and this is the last one. It just is greatest to least instead of least to greatest. So we're going to look at all these as decimals. So 3 times pi is about 3 times 3.14, which is about 9 point something. So 9 point something, let's say 4. And then 4 times the square root of 5. We know the square root of 5 is about 2.2 because it's a little greater than 2 because 2 times 2 is 4. So 4 times 2 is about 8 point something. So about 8.23 or so on. And then 5 times the square root of 4 is just 5 times 2, which is 10 because the square root of 4 is 2. So 2 times 5 is 10. So we are placing these in order from greatest to least. So you would go back to the original number that you had. So you would do 5 times the square root of 4 is greater than 3 pi. And then last, 4 times the square root of 5. All right, guys, that's it. If you made it to the end of this video, you get a secret for the test. This study guide is not for a grade, but I will count it towards extra credit. So if you can complete the study guide and turn it in to me, whether that be virtually through email or in person on paper copy, I'll give you some extra credit on your test. Let me know if you have any questions about the study guide. Bye.